Welcome to The Explainer. Today, we're diving into a genuinely fascinating economic detective story. It's all about how invisible administrative lines, just, borders drawn on a map, somehow seem to stop physical trade dead in its tracks. We're going to uncover how weird data, missing variables, and honestly some pretty basic math errors ended up creating this massive illusion that totally baffled economists for decades. Let's get right into it.
So here's the basic premise that really hooked economists. Think about a border between two incredibly similar, super friendly countries, like the US and Canada, right? They share a language, this huge border, very similar cultures, and obviously free trade agreements. Logically, a factory in Toronto should be able to trade just as easily with a buyer in New York as it does with someone in Vancouver. But when economists actually dug into the data, they found this massive disruption in commerce right at the border. The question is, why? Why would a simple, peaceful, totally open border cause such a massive, sudden drop in physical trade?
Well, the shock wave really started back in 1995. Economist John McCallum and later John Helliwell looked at trade data from 1988 and found something absolutely staggering. Canadian provinces were trading 22 times more with each other than they were with U.S. states of a similar size and distance. Wait, 22 times? It was this spectacular puzzle. It literally suggested that a simple administrative border was acting like a massive, invisible wall, making trade with the U.S. seem almost impossible compared to just trading domestically.
Section 1. Gravity and missing variables.
Okay, let's dive into this because an anomaly that big in international economics, it immediately attracts detectives. The first major breakthrough came from economists James Anderson and Eric Van Winkoop. But to get their breakthrough, you kind of have to understand the gravity model of trade. It's actually a lot like planetary gravity. This model basically says the massive size of an economy naturally attracts trade, while distance repels it, mostly because, distance adds transportation costs. But Anderson and Van Winkoop pointed out that earlier economists forgot a totally crucial missing variable: multilateral resistance, or in plain English, relative prices. You see, you can't just look at the distance between Toronto and New York in a vacuum. You have to compare it to the cost of trading with everyone else. If trading with Europe suddenly gets incredibly expensive, trade between Toronto and New York is going to go up, even if their actual distance hasn't changed at all. Now, what's really interesting here is seeing how the math evolved to shrink this puzzle over time. First, we had that massive original 22 times anomaly. But when Anderson and Van Winkoop added their multilateral resistance fix, using some numerical approximations, the border effect dropped way down to 10.5. And it didn't stop there. In 2008, economist Bas Strothoff looked at their nonlinear math and realized, hey, this can actually be solved analytically with exact log linear equations. By dropping the need for a rough approximation, Strothoff shrank the supposed Canadian border effect even further down to just a factor of 5. So the invisible wall was definitely shrinking, but it was still there.
Section 2. The Wholesale Hub Illusion.
Let's keep building on this because the investigation took a really fascinating pivot here. Economists Russell Hilberry and David Hummels decided to just stop looking at international borders altogether and start looking really closely at internal borders, specifically the borders between U.S. states. They were responding to this highly confusing finding by Holger Wolf back in the year 2000. Wolf looked at the data and found that trade within a U.S. state is over 4 times larger than trade between different states, which makes absolutely no sense, right? Under the U.S. Constitution, states are legally prohibited from restricting interstate commerce. No tariffs, no customs, no currency exchanges. So why on earth would a completely open state border appear to block trade by a factor of 4?
So Hilberry and Hummels did some foot-leather detective work and dug into the raw commodity flow survey data to figure it out.
and they discovered that previous researchers had basically mashed two entirely different types of shipments together: manufacturing and wholesale. Think of it like a hub and spoke system. The manufacturers are the hubs, right? They ship massive freight over incredibly long distances to regional warehouses. But the wholesalers are the spokes. They take those goods and distribute them locally over very short distances straight to the retailers. And here's the kicker: wholesalers almost never cross state lines because their entire economic function is just local, short-haul delivery. By mixing these two completely different supply chain steps together into one data set, everything was heavily skewed. It made it look like state borders were magically stopping trade, when in reality, it was literally just local delivery trucks doing their normal local routes. And on top of that wholesale issue, there were some really serious distortions in how economists were even measuring distance in the first place. Older studies were using imputed distances. That's basically just drawing a straight line between the biggest city in state A and the biggest city in state B. But actual physical trucks drive on actual physical highways, which take winding, indirect routes. Furthermore, firms just naturally move close to their biggest customers. I mean, if a glass jar manufacturer moves right next door to a food processor in the same state, the actual shipping distance drops to practically zero. When Hilberry and Hummels finally controlled for actual physical driving distances and removed those superlocal wholesale shipments, that mysterious 4x state border effect drastically shrank down to just a third of its size. The geographic friction wasn't caused by a political border at all. It was just the everyday reality of local distribution.
Section 3. The Nonlinear Math Twist.
This brings us to our final detective in this explainer, Daniel Diaz. In 2011, Diaz took everything we learned so far and applied some advanced mathematics directly to that original 1995 data that started this whole crazy puzzle. He wanted to know, what if the statistical tools themselves were creating the illusion? And this brilliantly illustrates the danger of bad statistical assumptions. We're looking at the ordinary least squares, or OLS method. That's the traditional linear math those early economists used, estimating the border effect at roughly 19 times. But Diaz pointed out a huge flaw. Taking a natural logarithm of a gravity equation with inconsistent or heteroscedastic errors creates a severe statistical bias known as Jensen's inequality. When he reran that exact same data using a nonlinear estimator called PPML, the border effect immediately plummeted to 10.6. Literally, just by fixing a statistical math error, the illusion was cut nearly in half. But Diaz had one final massive reveal for us. You see, previous models forced the math to assume that shipping a product 500 miles domestically carried the exact same penalty as shipping it 500 miles internationally. Diaz basically said, hey, let's just let the data speak for itself. And he used a much more flexible equation. And when he did that, the actual crossing the border effect completely disappeared. It became entirely statistically insignificant. The reality is simply that distance has a stricter, heavier penalty on international shipping than it does on domestic shipping. As for why? Well, it could be because domestic distribution networks are just way more efficient, or maybe the types of goods traded domestically are fundamentally different. But the border itself? It was never a magic wall. Section 4. Does the border exist? So over a decade of really rigorous economic detective work peeled back this illusion layer by layer. Remember, we started with that massive 22 times anomaly. But by controlling for relative prices, understanding wholesale delivery routes, and fixing some pretty gnarly linear math errors, that magical barrier was erased entirely. So the absolutely crucial point here is captured beautifully by this quote from John Helliwell. He originally posited that the fabric of national economies is tight-knit, and honestly, he was absolutely right about that part. Domestic trade networks really are incredibly dense and super efficient. But that massive 22 times border puzzle that sparked an entire decade of panic in international economics, yeah, that was largely a mirage.
It was just a statistical illusion built on missing price variables, misunderstood local delivery networks, and flawed linear math.
Which leaves us with a totally fascinating and maybe slightly unsettling question to ponder as we wrap up this explainer. If one of the most famous, heavily cited puzzles in international macroeconomics turned out to be so heavily exaggerated by basic statistical assumptions and missing variables, what other established facts about our world might just be a trick of bad data? The next time you see a shockingly high statistic about global trade, remember the border puzzle and ask yourself, what variables are they missing? Thanks so much for joining me, and keep questioning the data.